Okay, my name is Zach Anderson. My project is the dynamic honeypot. So what is a honeypot? A honeypot is a machine that is attached to a network that attempts to lure an attacker into performing some sort of exploit or attack on the machine. Researchers use honeypots to gather information on new attack methods or attack vectors. Companies may use it to provide dummy data on a honeypot to try to trick the attacker into um, stealing dummy data and essentially notifying the company that somebody is in their network. There's a lot of use cases for it, and it is important for security purposes. The issue with many honeypots nowadays is that they have one type of attack available, and if the attacker is not looking for that exploit, then they may skip right over that honeypot. Obviously, this could be an issue. For example, if corporations are using the honeypot to help detect if intruders are in their network, you want to get the highest click-through rate, for lack of a better term, as possible. With that in mind, my dynamic honeypot attempts to solve that problem. So if an attacker is looking for a particular exploit, the dynamic honeypot will see that the attacker is attempting to do something, and then from there the dynamic honeypot will spawn services, open ports based on what the attacker is trying to do. So, for example, if the attacker is attempting to is scanning the network for FTP or SSH, the dynamic honeypot will open up, will start running FTP or SSH and open up those ports, enticing the attacker to try something. So that is the main goal of this project, and so this presentation is the agenda for this presentation is as follows. The first thing I want to do is kind of talk a little bit of architecture, and then I'm going to kind of show a demo, walk through the program in a little bit more detail, and touch on some of the more important aspects. I'm going to show another demo at the end just to kind of summarize everything that we have done thus far, and you can see it all in action, and then talk next steps and talk about some of the things that gave me a little bit of trouble. So first thing, architecture. So what I have here on the left is my dynamic honeypot. Right here, as you can see, it is the dynamic honeypot is running on VirtualBox. It's running Ubuntu 18.04, and on the right side we have Kali Linux. This is going to act as my attacker. Yeah. So on the dynamic honeypot, you can see that there are three interfaces. One, two, actually let me blow this up so you can see this a little bit better. So there are three interfaces, one, two, and three. You can see that only the first interface is assigned an IP address right now. The other two are actually in the down state, so they are down, and they do not have IP addresses. The reason for the three IP addresses is imagine a scenario where this is deployed into a corporate environment. And imagine that you have three computers in this dynamic honeypot network. The first one, the first machine will be your listening machine. So if it detects if it detects that it is being probed for a certain port or a certain service, then it will notify the other two machines what's going on and tell it to tell the other two machines to start some services and open up some ports to invite the attacker in. And so that's what we're trying to accomplish here, but without the overhead of three different computers. We have these three interfaces. The first one will act as a listening interface. It will basically capture traffic via IP tables and all that. And if it detects that is being probed for a certain port or a certain service, then it will bring up these other two interfaces, assign them IP addresses, and off to the races. So the first thing that I want to do is, that's a little bit about the architecture and the reason for the three NICs. So the next step is to demonstrate an attack. Do a little demo. So what I'm going to do is I'm going to split this so we can monitor the interfaces as we go. So the first thing I want to do is we're going to run this Python command, and we are going to so this is the dynamic honeypot Python program that will work the magic for us. So right now there's nothing to see, no attacks have happened yet. So we're going to start off just scanning port 21. You can see our network interface right here, 10.02.10 is up, FTP is closed. If we run this again, you can see that the dynamic honeypot is now doing things. It has detected that somebody is probing the network. If we run this again, if we flop over here and this command, I am running Hydra using some dictionaries against FTP, and you can see that Hydra has received a successful login. You can now see that these other two interfaces are up and have been assigned IP addresses. And if we go back, we can see in our second Nmap scan that the IP addresses were found, the services are open, all that fun stuff. So the dynamic honeypot has finished running, and if we attempt to scan it again, you will see that that these IP addresses 10.02.236, 10.02.249 are no longer up and cannot be seen by other computers on the network, which is what we are looking for. So that right there is just a quick demo of kind of what happened, and the final result can be seen in this directory here, packet capture. So this is where the indicators of compromised files are produced, and if we want to open one up to see what it looks like, we can let's do what's the recent one, 21.24. So this is the latest one. And here you can see that we have a bunch of FTP traffic. You can see usernames, passwords, and then if we search for success, you can see there was a login, there was a successful login. So I'm going to minimize the Kali box while we dive deeper into the dynamic honeypot and what it actually did. So looking at this output, this is pretty much everything that occurred at really a high level. You can see where the interfaces were brought up and assigned. Yeah, so you can see down here these two interfaces were assigned these IP addresses, and this is where that happened. Then FTP started. Started capturing packets with TCP dump, and here's the standard output for TCP dump. And then we start cleaning up. So the cleanup is stopping the FTP servers, taking down the two interfaces, converting the PCAP to a CSV file, and then creating the indicators of compromise file, which can be seen in these steps here. So that's a quick demo. Now I want to go into a little bit of program detail, talk about some of the logic, how we arrived at these steps, and just talk a little bit deeper about what's going on. For this, I'm going to open up VS Code because it's a little bit easier to navigate through and see what's going on. So the dynamic honeypot is the Python file, is the main file that is ran and it basically calls all other files and functions and whatnot. So the very first thing that happens is we are going to analyze our log file that is produced by the IP tables. And what this will, and that's right here. So what this will give us is a list of ports that were recently hit. If 21 and 22 are both in that list, then we will randomly choose to run either FTP or SSH. We don't run both of them, mainly because that would be a huge coincidence if the attacker's looking for those two ports and both of them just happen to be opening on two different machines. So to kind of, I guess, obfuscate what we're doing here, we just randomly open up one. And just in full disclosure, right now the dynamic honeypot is only configured to for FTP and SSH. Obviously we could add more services, and that's one of my line items in the next steps piece of the agenda that I was going to talk about towards the end, and I'll dive more into what we could add and what the reason was I didn't add more now. But moving on. So as you can see, if both port 21 and port 22 were scanned, we're going to randomly choose one of them. Else, if it's just port 21, we'll just do FTP. If it's just port 22, we'll do SSH. If it's anything else, we do nothing right now. So to kick off FTP, we are going to go to the open ports file, Python file, and we are going to look at what is going on. So in the first thing that it'll do is grab a timeout value, and this is basically going to be used in the TCP dump command, and all that's going to do is just tell TCP dump how long to run for. Right now it's configured for a minute. We can make it longer, shorter. pretty easy to change there. But to start the VS FTP, we're going to come over here. Basically, what we're going to do is make some changes to the configuration file, and then start running VSFTP in the background. See that here. So back to the OpenPorts file, and it's very similar for the handle SSH. We call it bash script, and it's going to kick off SSH. So going back over here, so you can see where TCP dump started. Again, that is done right here. The timeout interval was 60 seconds. And then once TCP dump is complete, we'll run the cleanup service function, which is up here. The cleanup service function right now is I feel a little crude. I wasn't sure what the best method for killing FTP was, but from what I read, it isn't to use sudo kill 9, because that kills it. I guess the best word is not very cleanly. So that could definitely use some work, but I believe it functions for now. So navigating back over here, so TCP dump, we talked about that. So the cleanup started, and then we convert PCAP to CSV. Yeah, so that's done here, PCAP to CSV. I chose to use T-Shark here over TCP dump. Basically, I chose T-Shark over TCP dump because it was easier. T-Shark had a pretty simple command. I found more documentation on the output and the formatting the way I wanted it. I had a hard time doing TCP dump, converting that to a CSV, so I opted for T-Shark. And then we take down the interfaces, which is done here in the takedown interface bash script. So basically what we're going to do is use the IP command and awk to grab just the IP address. We are going to check if the IP address contains a value. If it does, we are going to take it down. So we delete the IP address, and then we take it down. Same thing here. And then we, so the cleanup was successful. Then we created the indicators of compromise file and moved it to this directory, which we looked at the file, but I just want to talk about how it's created. So for the indicators for FTP, basically we're going to read in the CSV file that the PCAP to CSV bash script created. That's not what I wanted. And then basically we are going to return any column that had FTP in it. So we're going to get rid of non-useful information. So this right here will basically return us what we saw earlier, where the username, passwords, any attempts to log in, transfer files, whatever it may be. That it kind of gives us just what we're looking for. And then something similar for the SSH indicators. Because SSH traffic is encrypted, there's not really much to tell. So what I chose to do was just print the first 100 lines for right now, just because at least we can get a source and destination IP fairly easily. So that covers the indicators of compromise files. So I would like to back up just a touch and look at how we bring up these interfaces and how we assign IP addresses, because I am kind of proud of how it does it. So, okay, so what we're going to do is okay. Actually, let's. So we're going to go. So whenever FTP is being started, the first thing it's going to do is call the bring up interface bash script. So what that does is it will attempt to go out and grab the IP address for this interface. If the IP variable has a value, is assigned a value, then we know that this interface already contains an IP address. So we do nothing. If it does not, if the IP variable does not contain a value, then we are going to bring up the interface. We are going to generate a random number between 100 and 250. We are going to append it onto the end of 10.0.2. Whatever our random number is, and then we will add the IP address to this interface. And then very similarly for our second interface, we do the same thing. We generate a random value between 1 and 100. We append it. The only difference is we want to make sure that it doesn't get assigned the same IP address as our previous interface. So to do that, basically I've just entered here a while statement. So while the previous IP address is equal to the one we just created, we're going to generate a new random number and add it to the IP address variable. So that ensures that we don't get duplicate IP addresses. Yeah, so I was pretty happy about that. So that kind of covers what the dynamic honeypot is doing for really the high levels. The only other thing that I could really touch on is the analyze log file, and all that's doing is read log file. So all that's going to do is read the IP tables log file, grab the last 100 lines, and we're looking for just for destination port information, and then that's going to write to a file in the temp table or in the temp directory. So so basically, if the machine has been hit with a port that we are interested in, it will be written to this file path here, temp _IP tables.log, and from there we can read that in and say, okay, this machine was hit. They were looking for port 21, and kick off the dynamic honeypot. So let me see if my notes have anything different. So that really sums up the program details. The next step would just be to look at another demo And I would like to show what would happen if we scanned both. So what we can see here is so we can see this one's kicking off FTP again. And then what I'll do is once this is done, I will kick it off. And remember, so it's running FTP again, even though we have both SSH and FTP that were scanned. And the reason for this is in this logic here, where if 21 and 22 are both in both in the ports that are being attacked or being hit, then we will randomly choose one of them. So it's possible, to get FTP, or it's possible to get SSH. So once this completes, I will kick off the dynamic honeypot again, and hopefully we will get something different. Well, I will just remove port 21. Actually, what I can do is shorten this timeout interval. So that way maybe we can do a little bit more testing, and I can be able to demonstrate that for you. So, and then once I show this, my next step is going to be talk about kind of next steps and what I think I can improve on, do better on. Again, this is only going to run for 15 seconds, and now I am going to just do port 21 or 22 just to simulate the SSH traffic. So you can see SSH is starting up. But yeah, so if they are both in the list, and I can actually show you the list here. So we could see that these ports are were the last 100 to be hit. So you can see FTP or 22 was hit right here. So next steps and troubles that I had. So I think an obvious one and really the first one to improve on is the real time port scan detection. So right now the dynamic honeypot will only kick off after a port has been one of our ports, so in this case 21, 22, have been hit. By the time an attacker hits one of our ports and sees that it's not open, he is very likely moving on to other machines, other networks. So improving the real time port scan detection is, I think, crucial, and is one of the next steps to implement. The issue that I was having there was in how So the issue that I was having was in how Nmap was scanning the subnet. So what I was doing is taking away the randomization, and I was also adding in a delay as well. But the issue that I had was that all the ARP requests came first. And since all the ARP requests came first, Nmap was only detecting interfaces that were up and had IP addresses assigned to them and that were responding. So by the time it got down here to the bottom, where it was running the SYN and request and resend ACK, it was too late for the interfaces to come up. So that was kind of the issue I was having. The solution that I looked at doing was to try to capture ARP request going out of the dynamic honeypot. So basically response ARP request or ARP packet, and once it detected one of those, maybe kick off the dynamic honeypot. But the downside to that obviously is that ARP messages are occur frequently, and that wouldn't really be the best solution. So I wasn't sure how to solve that issue, but it would definitely be one of the next steps to look into. Another next step is to add more services, obviously. So right now, as I said earlier, I just have ports or services, SSH and FTP available. I think for the purposes of this demo, I think 2 services sufficed, right? I mean, I could have added in MySQL, I could have added in Telnet, I could have added in 15 more services, but at the end of the day, I would have been showing you really kind of the same thing for each service. I think this really is a great example of what is possible with the dynamic honeypot, and that adding more services is certainly a next step of mine. So that is all I have. Thank you for listening.